Hi, my name is Milan, and in this video I want to introduce you to change data capture, or CDC, which is a technique for tracking the changes made to your database in real time or near real time. Whenever something occurs in your database, the CDC server is going to pick up this change and allow you to react to this event. Based on this, you can implement some very interesting things. Now, I spent quite a bit of time trying to make change data capture work with Postgres and RabbitMQ and MassTransit. The documentation that I found out there wasn't as good, so I'm making this video hoping that it's going to help out someone trying to implement the same thing. So let's start by explaining how change data capture works and where it fits inside of a distributed system, and I'm also going to mention what are some of the use cases for CDC. Let's imagine that we have a primary database inside of a microservice. This could be a relational database or a document database, and whenever we want to make changes to this database, we're going to execute some operations. This could be insert statements, update statements, or delete statements. How most databases work when you try to execute some of these operations is they generate a set of commands or transaction logs that are appended to the database state. So by replaying these transaction logs, we can come up with the final state of the database. Now, because databases expose a way for us to access these transaction logs, we can also do some interesting things. And this is where change data capture comes in. This is typically going to be another server or another application that is running alongside our database. And what we can do is connect the transaction logs of our primary database to the change data capture system. The CDC server is going to read the transaction logs of our primary database and allow us to react to these events. For example, when we insert a record into our primary database, this is going to generate a log statement that is going to be picked up by the CDC server. From here, we could do a couple of things. For example, we could stream the same log statement to another database, and this allows us to implement database replication. Now, mind you, the source database and the target database don't necessarily have to be the same database type. This could be a SQL Server database, and we could be streaming to MongoDB. The trick is how we are going to convert the respective log statement from one database into something that the other database understands. But this is a bit outside of the scope of this video, so let's continue with our original discussion. So we have our logs in the change data capture, and we can stream the insert, update, and delete statements into our target database. But we could also stream this into a queue, for example. There's nothing stopping us from using CDC for something like this. And then we could have multiple subscribers to this queue that will be reacting to these events. Now, if we want to have multiple different consumers all receiving the same message, we would probably want to use a topic, but I think you get the idea. So what I want to show you in this video is how we can take a source database that's going to be Postgres and connect it to a change data capture server, which is going to be Debezium. And we're going to use Debezium to stream updates made inside of Postgres to a RabbitMQ instance. And then we're going to react to these messages inside of our .NET application using MassTransit. So let's jump into the code and I'll show you how we can implement this. Here's the system that I'm going to use for setting up Debezium. I have a .NET 8 web API, which is configured to use Serlog for logging and Seek for processing our structured logs. I also configured OpenTelemetry, and I configured the OpenTelemetry exporter to stream my traces into Seek. We also have an EF Core database context that is connecting to Postgres, which is running inside of a container, and a MassTransit configuration using RabbitMQ, which is also running inside of a container. As far as our database entities go, we have only product, and I only made a dummy endpoint so that we can fetch the product. So the more important part here is what our system consists of. So we have a web API, a database, a RabbitMQ instance, which is going to be our message broker, and we have a Seek instance so that we can see what is going on. What else do we have when it comes to functionality? There is a background service that is going to execute every 5 seconds and is going to run this generate products method. And all we have going inside is using Faker, which is coming from Bogus, to randomly generate 10 products and insert them into the database. And why am I doing this? Well, I just want to constantly keep writing to my database so that I have something to react to when I introduce change data capture. So this is merely for the purpose of our demonstration. Now let's see how we can configure Debezium inside of our system. Debezium is an open source change data capture server that allows you to stream changes from your database. So we can easily react to insert, update, and delete statements made inside of our database and stream the changes to various connectors. servers. Now in our example, we will be streaming these changes to RabbitMQ. But let's also mention what are some of the use cases for using change data capture. You can use this to run an ETL pipeline, which is extract, transform, load. You can use this for database replication in your distributed system. You can use this for running projections to generate your read models. This is practical if you want to do CQRS with multiple databases, for example. You can also use this to implement an outbox using transaction log tailing, where you would be listening to changes made inside of an outbox and then publishing these changes to a message broker. And this is actually what I am trying to build with Debezium, but we are going to tackle this in a separate video. For now, let us see how we can introduce Debezium into our distributed system. So Debezium is available as a Docker image, so I'll be adding it to my Docker Compose setup. I'm going to be using the Debezium server image, and I will use the latest stable version, which is 2.7. Now this is going to depend both on my database and the RabbitMQ instance. And now the tricky part is configuring a bunch of environment variables. Another option to configure this is to define a configuration file that you will have to pass to the Debezium server, but I find the approach using environment variables more explicit and more manageable for my use case. So that's what I'm going to show you. So I'm going to introduce a set of environment variables and then walk you through what they are and why we need them. We are configuring a name for the Debezium server. Then I'm setting up some Debezium specific configuration, and I'm also turning off JSON logging in the console so that we can actually see what is going on when we jump into the logs for the container. The next set of environment variables are going to relate to our Postgres instance, and this is how we can connect Debezium to our Postgres database. So let me walk you through what we need to set up here. The first thing we have to configure is the Debezium connector for Postgres. This is the name of the connector that we will be using, so you just have to specify this. Another important thing is you have to specify the plugin name to PG output, and this is how we are going to read the write-ahead log from our Postgres server. Then I'm configuring the connection to our Postgres instance. The host name is the name of our service here, which is Postgres, and you can see I configured the username and password to also be Postgres, and the name of our database is Commerce. So back in my Debezium configuration, I'm using these values to configure the connection to my Postgres instance. And then is the important part where we are configuring what are the changes in the database that we want to react to. So we want to listen to changes in the public schema. You can also limit the number of tables that you want to include in CDC. And in this case, I'm just listening to the products table. But if I wanted to listen to more tables, I could specify them here. And then I'm specifying a topic prefix, which is a prefix that Debezium is going to append to the topic where it's going to publish a message containing the changes that were made in the database. This part is a bit annoying for me because the setup here isn't as flexible with RabbitMQ, and if you start digging into Debezium, you will notice that it's mainly designed to work well with Kafka, and I didn't want to use Kafka for this video because it would make it too complicated, and there are already a bunch of examples for this, so I wanted to show you how to make this work with RabbitMQ. And that is the next thing that we need to configure. So I'm going to add another set of environment variables, and this time I'm going to configure my Debezium sync. And this is where I want to send my CDC messages when I pick them up from the write-ahead log. So we're going to use the RabbitMQ sync, and I'm just configuring the connection to RabbitMQ, and you will find the same values in my setup of the RabbitMQ container. The only thing that I added additionally is configuring the RabbitMQ exchange name, which is called product updates, and this is where I want Debezium to send messages. Now, unfortunately, this doesn't actually work out of the box, or maybe I just wasn't able to figure it out, but let's take it one step at a time and I'll show you what the problem is that we are running into. One more important change that we have to make for CDC to function correctly is to update how we are configuring our Postgres container. So I have to add this command to set the write-ahead log level to logical, because this isn't the default write-ahead log level, and this is how Debezium is able to connect to my Postgres instance and start listening to the changes inside of the write-ahead log. Now this will be enough for our initial setup of the Debezium server. Now let's go back to our code and configure a consumer on RabbitMQ. So inside of the RabbitMQ setup, I'm going to define an endpoint by calling the receive endpoint method, and here I need to define a name for a queue that is going to accept messages for a given consumer. So let's call this queue the product updates. And then I want to customize this endpoint. So I'm going to specify a delegate here. And what I want to do is to turn off configure consumer topology because I want to set this up myself. The second thing I have to do is to update how we are going to process our messages. Because Debezium is going to send JSON messages to RabbitMQ, we have to manually configure support for this by using the raw JSON serializer. By default, MassTransit expects a message to have a certain envelope that also contains information about the consumer that is supposed to consume a given message. Now, because we will be consuming raw JSON from Debezium, we will have to do this manually. And now I'm going to add my consumer implementation, which I already prepared ahead of time so that we don't spend too much time on this. But this is just an iConsumer implementation where the message type is a product update, and this is just a plain copy of the product entity that I have in my database. It contains an ID, a name, a description, and a price. Unfortunately, this isn't exactly the format of the message that we will get from Debezium, but we're going to fix this, and I'm also going to explain what you will need to do if you want to react to all types of changes made in the database. For now, let's just accept that we are consuming a product update message, and I'm just going to log this into the console. Let's, for example, also destructure this, and I'm going to return a completed task. Now let's configure this consumer with MassTransit. So I'm going to say x add consumer, and I'm going to specify the product changes consumer, although I should probably name this to product updates consumer. And I also want to configure my endpoint to consume this specific message. So I'm going to say consumer and then specify the product update consumer type. And let's also pass in the bus registration context. So this is what I need to set up with MassTransit to be able to receive a message on the product updates queue and then have it be consumed by the product updates consumer. And I'm also adding support for processing raw JSON messages. So now I'm going to start my application, and if I open up Docker desktop, you can see that all of my services are now successfully running. If I go into the products API, you can see logs from our background service that is inserting 10 records at a time every 5 seconds. However, my Debezium container is down. Now I'm going to explain why this is happening in just a moment, but first let's go into our RabbitMQ instance, or rather the management dashboard. And this is because I want to show you the exchanges and queues that are configured on our RabbitMQ instance. So here is the product updates exchange, configured as a fan-out exchange. Now if I go into this exchange type, and exchanges are kind of similar to topics with other message brokers. Now what's important here is that we have a binding from this exchange to a queue with the same name. So it's actually this queue called product updates that we are going to be consuming messages from inside of our application. If I go into this queue, I can send a JSON message from here, and let's do that by sending a request to the products endpoint. And I'm just going to grab the first record here, paste this as a JSON message, and I'm going to publish this. And you will see that we hit a breakpoint inside of the product updates consumer. And if I take a look at the message, it contains the same data that I just sent using raw JSON. So you can see that we are able to consume messages as raw JSON. So this is the first step in making this work with Debezium. Now, if I open up Docker desktop again, and go into my Debezium container, you will see that we are getting some errors. And if I try to restart this, it's going to try to pick up the logs from our database, which it will be able to do. If I keep scrolling, I can find a log, hopefully, and here it is, that we are exporting data from the products table. So the connection to our Postgres instance seems to be working. However, if I navigate to the actual error here, we're going to be able to decipher why Debezium is crashing. And what it's saying here is that there is no exchange called commerce public products. And this is where Debezium is trying to publish the logs that it picks up from our Postgres instance. So we can solve this manually, and I'm going to show you another way to solve this in just a moment. So we have to go to our exchanges and add a new exchange that I'm going to call commerce public products. So let's add this exchange. I'm going to make it a direct exchange. If I go to the bindings for this exchange, I can say I want to add a binding to another exchange, and I'm going to specify the product updates exchange. So let's add a binding, and you can see that this is working. And now if I go back to Debezium and restart this, we should see that it's going to start to publish messages to our server. So we are seeing some logs here. If I go into my API project, you can see that we are receiving product changes. However, they are all empty. We're going to tackle this in just a moment, but you can see logs from MassTransit that we are getting some messages from RabbitMQ. If I add a breakpoint in my consumer and we take a look at a given message, you will see that all of the properties are empty. Now I'm going to stop my application server and let's go back to our RabbitMQ dashboard and let's go to the product updates queue. Now here, I'm going to say that I want to get, let's say, 15 messages, and you're going to see what are the messages that are currently in the queue. And these are actually the updates that are streamed from Debezium into our RabbitMQ instance. Now, if I take a look at one of these values, and I will jump into VS Code so that we can actually take a look at what's inside, you can see that this is a JSON document with a specific schema. So there is the schema property, which contains some structured data inside. Then there is the payload. So this is the base schema of what Debezium is sending. And then if I take a look at the schema itself, it's actually describing the message that we are sending to RabbitMQ. So these are the individual fields and the data types that are being sent. So we are wrapping the database logs with an envelope. And then in the payload section, you can see the before and after sections, which contain the actual raw JSON. So I want to pull this data out of the envelope and make this value the only thing that Debezium is sending to my RabbitMQ instance. And we can actually do this relatively easily. Now, Debezium supports the concept of transformations that you can apply to the individual messages. And I'm going to add two transformations, the unwrap transformation and the reroute transformation. So you can have more of them. The unwrap transformation, I'm going to specify the extract new record state transformation. So this is a built-in transform that you can apply to your messages. And what this is going to do is extract the value in the after record in our payload and use that as the message. Now, I also had to specify the Debezium format value as JSON for this to work. And I also set this environment variable to false. And I also configured decimal handling mode to string so that it would send numbers as strings in my JSON payload. If you recall earlier, it used a structure to represent the price of the product. The second transformation here is configuring the routing or rerouting to where we want to send this message on RabbitMQ. So let me explain what is going on here. I'm using a biological table router, which is another built-in type. Then I'm specifying a regular expression to pick up the topics that I want to reroute. So in this case, I want to capture messages being sent to any topic that matches public products. And if you recall, Debezium is trying to send a message to the commerce public products exchange. The reason I'm doing this is so that I can define a replacement when we have a match on this regular expression, and the replacement should be product updates, which is the exchange and the respective queue that we have configured with MassTransit. Based on the documentation, using this alone should have worked, but it didn't when I was trying it out. So I had to also add this setup here using the key field with the same regex and replacement, and only when I applied these changes was it able to function correctly. So let's start the application again. And if I open up the logs for the products API, you can see that we are still receiving the logs from the RabbitMQ broker. So our setup with Debezium seems to be working. If I go into the Debezium server, you can see that the connection to Postgres was established and it is successfully publishing messages to our queue. If I look for product updates here, you can see that our environment variables are definitely applied in the Debezium server. So our setup is working. And one more way I want to confirm this is by going into the RabbitMQ dashboard, and I'm going to go into the exchange that I defined earlier, and I'm going to delete it. This is also going to get rid of the binding, and if everything is working as expected, my Debezium server should still be running, which it is. And if I open up the products API, you can see that we are still receiving messages through change data capture. And if I place a breakpoint here, we can also confirm that the message that we are getting contains the actual value of the product. So let me stop this, and I'll go back to RabbitMQ and check the product updates queue, and let's fetch, for example, 15 messages. and this is going to give me the messages that are currently in the queue. And if you take a look at the message payload, you will see that this is just the raw JSON of the product record that was inserted into the database. Now, if you want to handle update and delete operations, you could also use this approach, where the JSON payload is going to contain the latest state of the record. Now, this will function a bit differently for delete statements, so I'm going to leave some useful documentation links below this video where you can check this out. If you're enjoying this video so far, then make sure to smash the like button under this video, and I want to discuss a few more things that I have on my mind. Now, running Debezium in a local environment and in production are two different things, and there is a bunch of stuff that I still have to figure out, but what I'm trying to implement with this is to have Debezium stream outbox messages to a queue on RabbitMQ that I'm then going to process with MassTransit. Whenever I manage to implement this successfully, I'm going to make a video, and this would function as an alternative to long polling the outbox table using a background job. So instead of having a background job process the outbox messages and publish them to a queue, or even publish them in memory using Mediator, we would have Debezium listening to inserts on the outbox table and then instantly publishing those raw messages to a RabbitMQ exchange. Now, the tricky part here is how you will configure this exchange to route the messages to the respective queues so that you can actually consume them from your application. If you go by this approach, you will have to listen to all possible messages, and this might introduce some noise. I would like this to be more granular, where I can actually save a message into the outbox and then be able to consume the concrete message type with MassTransit. So I'm going to post an updated video whenever this is ready. And if you want to learn how to implement the outbox pattern from scratch, then you should watch this video next. Check out my clean architecture and modular monolith courses to improve your skills. And until next time, stay awesome.